Today we are resuming radian measuring. So far, we've completed converting between degrees and radian measures. We looked at radians and degrees. Secondly, we looked at determining the trig ratios of angles in radians. And look at one problem involving radians as a trig ratio. So we've completed three of goals of 6.3 radian measure. We'll conclude 6.3 by looking at determining angle measures given a terminal point. So this is the fourth goal of 6.3, looking at radian measure. At the end of the lesson, you will complete practice question number 9 and number 10 on page 508 of your textbook. And from your example booklet, it's this one here, you'll want to complete pages 15 to 19. And they are all on lesson 3, which is on radian measure. So converting degrees to radians and radians to measure. So they're all similar. And then we'll be looking at angle measure given a trig ratio or a given point. So that's what we'll be looking at the past few days. And today's example that I'll go through will be an example of the assignment questions that you have. So this is our goal for today, and that's your assignment questions. So the first question regarding determining angle measures given the terminal point is example 4 in your textbook. So in this question, you're given a terminal point, -9, -5 of this angle in standard position, and you're asked to find to the nearest tenth of a radian the possible values of theta in the domain -2 pi to 2 pi. But recall now we're working in radians rather than in degrees. So 360 degrees, so we're looking at both negative and positive. Just recall whenever we have a quadrant, going counterclockwise is positive, and going clockwise is negative. So we go around this, if you look at this path here, it would be -pi, continuing -2 pi. And if we were to look at positive, so positive pi, and if we continue 2 pi, clockwise and counterclockwise, just to recall. Now, the next part, you're given secant theta is 2.5 to the nearest tenth of a radian, determine the values of theta in the domain -2 pi to 2 pi. So let's look at A. The first thing you would like to do is just do a sketch. So sketch a diagram of the terminal point. So we'll look here. Oops. And the point is -9, -5. So -9 is here, -5 there. So that's my point here. So that's my terminal point, -9, -5. I call that P. So this is origin, the x and y axes. And just recall now this becomes pi over 2 pi going in a counterclockwise. This is 3 pi over 2, and this is 2 pi. Now I'm just going to make this a little bit thinner. Now, we're given, remember your CAS rule, meaning all cosines are positive here, all the trig ratios are positive in this one here. We have all. Only the sine is positive here, and the reciprocal of sine is cosecant. And this is tangent. Now, tangent is positive in this quadrant. Now, remember your tan theta, it's y over x. So we've given x and we've given y. So right away, we can find the reference angle by using the tan of this. Because you're using what's given. You don't need to find the r value because we can use a tangent, okay, so tan, to find theta. We're going to find, we need to find this angle here, but we'll find the reference angle. So that's our goal now, is to find this reference angle. Once we know the reference angle, we add theta, pi to it to give us theta. So this is our, we want to find theta. So I'll remove this guys here. So we have tangent. So we can put right here, tangent theta is positive in quadrant 3. So tan theta, we know it's y over x. What is what? We know x is equal to -9, y is equal to 5. That's given to us here. So tan theta is -5 over -9, which is equal to 5 over 9. So since we know the terminal arm, which is one here, lies in quadrant 3, and the reference angle, oops, I should put that here. The reference angle is, now we'll have to use our calculator here, is 10 5 over 9. So now I'll use my calculator. I'll make sure I'm in. Okay. Okay. I got my calculator here with me here. I'll walk you through this example. I want to make sure you're in. Now, when you go to your whatever calculator you're using, make sure you are in radian mode, not in degrees. So I want to make sure you're in radian mode. If you want, and I can write that here. Radian mode. So make sure you're in radian mode. So I'm there in radian mode now. Okay, quit that. Now I want to inverse, so I want to find the measure of the angle in radians. So second tangent, 5 divided by 9 equals 0.507. So we'll write that as 0.5070, and this goes on. So now that's the reference angle. Okay. So the reference angle, which we have here, is 0.507. So theta is pi plus 0.5070. So now I go to my calculator now and I plus that pi. So the angle is 3.648, but we leave that to what, 4 decimal points. So we leave it at 4. So that's which is equal to 3.648. We can go on. So that's your angle in radians. So radian is one of those numbers. It's more or less neutral. So the angle between now, so the angle between now we're asked to find between 0 and 2 pi and 0 and negative 2 pi. So let's do the first one. Between 0 and 2 pi is 3.6486. Now the angle between negative 2 pi and 0, now we're going to reverse, which is negative theta here, if you want to. So now we know this is 3.64. So we subtract it from negative 2 pi. So it's equal to negative 2 pi plus 3.6486. So I'll highlight the answers here. So our first answer which, if we were to add that, we get here, go back to my, so negative 2 pi. Oh, get it. I didn't do this correctly. Okay, let's do this again. So we have negative 2 pi plus what, 3.64? 3.6486, and it goes on. So we get negative 2.63. 6.345. So a possible angle measurement for positive theta, it would be 3.6486. So one of the possible values for theta in the domain negative 2 pi, the 2 pi is 3.664 positive, and you have negative 2.6345. We can approximate this as approximately 3.6, and this could be approximately negative 2.6. So it goes over again. The first thing you want to look at is to do a sketch. Find a quadrant. The terminal arm is located. And use a tan ratio to find the reference angle. Now you can use sine or cosine, you get a reference angle, but you will have to go about finding the hypotenuse, the r, which is extra work which you don't need. But you can try it, you should get the same answer, reference angle. Now part B, given secant theta is 2.5, to the nearest tenth of a radian, determine the value of theta in the domain negative 2 pi to 2 pi. So we'll do a sketch now. Let's look at B. So we'll sketch of what we're doing. Now look at this. We have secant is theta is 2.5. Now if we look at our graph, we know secant, which is the inverse. We can write that here. Secant theta 2.5. It's the inverse is cos, right? Cos theta. Right. So remember, we know we have CAST rule here, C-A-S-T. So cosine is positive in quadrant 4 and quadrant 1. So we can say here, so we have cos theta, or the reciprocal, I should say, cosine, the reciprocal is 1 over secant, which is 1 over 2.5. So secant theta and cos theta are positive in quadrant 1 and quadrant 4. So quadrant 4 and quadrant 1. So we'll use cosine. So in quadrant, let's look at in quadrant 1. We're going to find theta. So we're going to find the reference angle. So we're going to find this reference angle first, right? So theta, quadrant 1 theta, the reference angle is, so we'll find that. We said cos negative 1, which is 1 over 2.5. And we'll have to use our calculator for this here. Okay, we go back to make sure we're in radian mode, which we are, and clear. So we have second cos So we have 1 divided by 2.5. And that will give us 1.159. So which is 1.1592, and it goes on and on. So now this is 1.592. So that's in quadrant 1. So in quadrant 1, theta is 1.592. Goes on. Now we're going to define in quadrant 4. We can continue. Now we know what this is, right? So we're going to subtract it. So this is 2 pi here. So in quadrant 4, so theta will be, since we know this is 1.592, to go all the way around now, we take 2 pi and subtract it to find the angle all the way to here. So we know this also is equal to 1.592 minus 1.592. So I'll use my calculator here. So I'm going to put here plus, so we got to multiply by -1, so I got a negative here, plus 2 times pi, give me 5.1239. 1239. Now we have the positives. Now we need to find the coterminal. So the coterminal is going toward the negative now. So the coterminals with these angles here, with 1.592 and 5.1239, right, will give us the angles between 0 or -2 and 0, I should say. So the angles between -2 pi and 0. So recall, this is 1.592. So the reference angle here will also becomes negative. So that'll give us negative 1.592. And to the reverse now, so it will be the inverse. So continue to and negative 5.1239. So the possible values of theta are approximately, we have 1.592. Oh, 1.5. Oh, 1.15. Sorry, this is 1. It's supposed to be. Now let's do this again. Now I got this. It should be 1.159. Oh, this is here. It should be 159. And this should be given us 12. Okay, got this all right. 1.2. So they are approximately 1.12. We have 1.15. Okay. Then we have next would be 5.12. And now we have 1. There should be 2 here. Should be 1. Negative 1.15. And the final one will be negative 5.12. Oh, I'm going 2 decimal places, but I look back at my question here. It says here nearest 10th, so we'll have to change that. So we have to do 1 decimal point that's requested. So this would be 1.2. This would be 1.5.1. I'll change all these because they want us to, the answer required 1 decimal place. So this would be 2, and this is negative 5.1. So make sure I got these right. Okay, so here's your, I'll go back to my original question. So you're given secant 2.5 to the nearest 10th of a radian. Determine the value of theta. Step 1, we find the quadrant. Cos or secant is positive because it's given as positive. And we use the inverse of cos, which is 1 over secant, to find our reference angle. We find the reference angle is the first angle of theta, this one here, which is 1.159. Now I forgot to put my 1 there. And so in quadrant 1 and quadrant 4, it's your angle when you're coming from counterclockwise direction. The coterminal, right, give us the angle of 2 pi and from negative 2 pi and 0. We found it's negative, so it's a negative of it. So there's our final answer. So possible values of theta. So let's quickly review the question. So you're given a terminal point. The first thing you want to do is to do a sketch, define what quadrant it's in. And because you're given a terminal point, there's no reason to go and find the r. You go straight to tangent, and that will give you the reference angle. Once you know your reference angle, you can go ahead and find 7. So the first, so theta, it's because you're going counterclockwise, is pi plus 5.7. And secondly, you're asked to find from the clockwise, so negative. So we know what the positive is, so you subtract it from negative, you take it from negative 2 pi, and that will give you your angle between negative 2 pi and 0. In the second one, you're given the angle. So first of all, do a sketch where it is. Whereas if this was negative, then this will be in these 2 quadrants, quadrants 2 and 3. But since secant is positive, we have to use the quadrant is positive in. And the easiest way to go about doing it is to find the inverse of secant, which is cos, which is the inverse of cos. So to find secant, find the inverse of cos, and that will give you your reference angle. And use the reference angle to find theta. In this case, theta was pretty straightforward because the reference angle is given here. Okay, I'll go ahead and do one more. This is check your understanding question. I'll do one more example. And it'll follow the same pattern as this question here. You will also, the examples given on the page 508 are very similar to the ones I'm doing right now. So let's go ahead and do the first one here, part A. So given a terminal point of angle theta in standard position to the nearest tenth of a radian, determine the possible values of theta in the domain negative 2 pi and 2 pi. So here we're given the terminal point again. So the first thing you want to do again here is to do a sketch. Okay. So we are going to sketch. So negative 4, 3, which is about negative 4, 3. It's about here. So it's my x, y. So P is negative 4, 3. So you'll want to find theta. So first thing you want to do, we're going to find our reference angle here. Now, this is in quadrant 2. And in quadrant 2, remember, cos CAST 10 will be negative in this quadrant here. But it really doesn't matter because we just want to find the reference angle here. This would once we find this reference angle, we will subtract it from 2 pi, because here you have 2 pi, sorry, 1 pi. Pi here, this is 2 pi over here, to find theta. And between negative 2 pi and 0, we will now subtract our theta, or we add it to negative 2 pi to give us the reference, the angle for between negative 2 pi and 0. So step 1, we sketch a diagram, which we did here. And we know that tan theta, now this is my x and y, which is y over x, and this will give us 3 over negative 4. Now, we're not going to use negative 4 because so we need to find this reference angle here. So the reference angle, let me make sure that my calculator here already, I think it's, so we have 10, 1. So we'll have 3 over 4. Now, if you use negative, you'll have a negative answer, but you want, this is a vector quantity, we'll make that positive, so we make this positive. And this will give us now, let's go my calculator here. So second tangent, 3 divided by 4. 0.6435. So 0.6435. So a reference angle is 0.6435. So that's what this is here. So theta will be equal to pi minus 0.6435. So that's what we have, 0.64, and write it in here, time here. And which is going to give us what, 2 so multiplied by -1, which is negative plus pi 2.49, so which is 2.4980. So that's theta. Now, this we can put that. I'm going to highlight that answer for us. So theta going. So that's one possible measurement. So now, so this is the angle between 0 and 2 pi. Now, to find the angle between -2 pi and 0, so the angle between -pi and 0 is, that is, now we have to find that is coterminal with what we found here. Remember, there are infinite number of coterminal, but we are restricted to this domain here, 2.4980. So now we go into reverse now, so which is -2 pi plus 2.498, which gives us -3.7850. So 3.7850. So theta between -2 pi and 0 is equal to so now we can, so now the angle from here to here is -3.7850. By the way, and it's a good way to, one way of remembering this, because we're going in a negative angle, which is clockwise. Once your reference angle would be like your pi, which is 3.14159 approximately. So you know the angle is greater than pi, so it has to be greater than 3.14. So it's really 3.14 plus 0.6435. It's another way of looking at it. So finally, we see possible values of theta are approximately, we have here 2.4 or 2.5, here right now. and negative 3.8. So those are your two possible measurement of theta. So we can, that's the final answer. Part B, the line across there, given cotan theta is negative 2 to the nearest tenth of a radian, determine the values of theta in a domain negative 2 pi to 2 pi. So let's look at B. Now, you're given cotan theta is negative 2. Now, the inverse of cotan is tangent. So we have, so tan theta would be inverse of this, which is 1 over 2, 1 over negative 2. So if we were to do quadrant here, so where's tangent is negative, right? So tangent theta is negative. So remember Kant's rule. So tangent is negative in quadrant. These two quadrants. So we say the terminal arms now. Terminal arm of angle theta is in quadrant 2 and quadrant 4. So we'll use this to find your reference angle. Remember, you always use your inverse to find your reference, your angle. The reference angle now, this angle here or there. The reference angle is angle between 180 and the angle itself. Reference angle is, so we do tan 1 over 2. So we'll go ahead and try that. So we have second tangent, 1 divided by 2, it is 0.4636. So that will be in quadrant 2 here. So we'll find that one first, but that's our reference angle. So now this is in 0.4. This is my calculator again. 4636. So in quadrant 2, theta, now this is pi here. So this is 0.4636. To find theta, it'd be pi minus the reference angle, which is pi minus 0.4636. So I'm going to multiply that by -1, it will give me negative, plus pi is 2.68 or 2.6779, which is 2.6779. So the first one we have is in quadrant 2, That's what it is. Now we need to find quadrant 4. So in quadrant 4, theta. Now we're looking at, this is our measurement from here to here. So we're going to continue all the way. This is our reference angle. So there are a number of ways to do this. So the easiest one is, you notice the reference angle is 0.46. This is also 0.4636 goes on. So now it would be 2 pi, which is a 2 pi over here, minus 0.4636, which is 2 pi minus 0.4636. You can do that because we know the reference angle is over here. Now, if it's over here, it might be a different story, but it's in quadrant 4. So that conclude to be, okay, what would that be? So 2 pi minus, so we have 2 pi minus 0.4636, 5.8195. So that's in quadrant 4 theta is. Now we need to find the co-terminal angles between negative 2 pi. So now we find those two now. So the co-terminal angles between negative 2 pi and 0. Okay. So they are, so that's equal to, so you have negative 2 pi. Now, remember you're going clockwise direction. We know this is in quadrant 2. Let's find the first one here. We know the angle theta here is 2.67. So from here to here is 2.67. Now to find the angle from 0 going to negative 2 pi, so it will be negative 2 pi plus this measurement here, which is 2.6779. That's one way of doing it. That's not the only way. You could have added 0.4636 and be negative here and negative pi, and you'll end up with the same result. Which gives me negative 3.6052, and the other angle here, it will be negative, let's see, because we go into this direction here, is negative 0.4636. So theta, and so we have negative, theta will be negative 0.4636. So we can conclude, so the possible values of theta are approximately, we have 2.7 here, we have 5.8, and we have negative 3.6, and negative 0.4. Well, we can approximate it 0.5. Yeah, we can go to 0.5. Round up to 0.1. They ask us the 1 decimal place. So I said before, you could use sine or cosine to find the reference angle, but it's not necessary in this situation because you're given the x and y, so use that in tangent to find your reference angle. Once you know your reference angle, you can find the coterminal angles. The second part, you're given the cotan, you do the, or even tan, you find what quadrant is in by doing it. Always start with a sketch. It helps to give you a visual representation of the problem. I want to try to give you one other example, which is on question 14 in your textbook, page 499. For each trig ratio, determine exact values for the defined trig ratios for theta in a given domain. So you're given cotan, or cosine, is 2/3. So we just want to find between, in this case, they give you between 0 and pi. So here we have, we do a sketch for the first one here. Let's look at A. And here you're given cos now. Remember your cos here in quadrant 1 and in quadrant 4. So cos here we have you have a wonderful circle here. So first of all, let's look at the cos here. So we have cos theta is 2/3, which is x/r. So we're given the point, right? So here we have the point 2, 3. So now we're dealing with only in quadrant 1, because over here, the x is negative, so we're only going to deal with quadrant 1. That tells me I'm working quadrant 1 only. So we have x is equal to 2, r is equal to 3. So you want the other 5 trig ratios, right? So we need to find y. So to find y, we're going to use x squared plus y squared equals r squared. So we have 4. So we have 2 squared plus y squared is equal to 3 squared, which gives us 4 plus y squared is equal to 9. So we have y squared is equal to 9 minus 4. Go ahead to my right here and conclude y is equal to plus or minus square root of 5. Now, since cos theta is positive, so we conclude the terminal arm lies here. in quadrant 1. And therefore, y is positive. So this has to be positive. So, and y is positive, right? That's why I can conclude here. Oops, this is my select point. Sorry, that's 2. Now I found my y. There we go. Well, that's right. So I didn't know y there. So here we have secant is positive. So we need to find the reciprocal of cos. So now we have cos is 2 over 3. So secant, let's do them all. Secant theta, which now is going to be r over x, which is r over x, and that will give us 3 over 2. Sine theta is y over r, and now that will give us root 5 over 3. And cosecant theta is r over y, which is a reciprocal of sine, so they'll give us 3 over root 5. Remember, they should all be positive because in this quadrant, all of the trig ratios are positive. We have tangent theta, which is y over x, and my y is root 5, and x is 2, and cotan theta is x over y, which is 2 over root 5. So these are my other 5 trig ratios. Okay. Now, if you want to find a reference angle, it doesn't matter which one you use. I will go straight to this guy here to find my reference angle. So my reference angle so let's do the value now. I now the nearest tenth of a radian determine the possible values of theta in domain. So let's find a reference angle here. So the reference angle, let's put that up here. Sorry about that. So I'm looking at the second part. So now we're given the angle, which is cos, and you're asked to find out the reference angle. So the reference angle is cos, so just 2 over 3. Now we're going to take this here. This second cos 2 divided by 3, 0.84, which is equal to 0.8410. So that's 1 now. This is, I'll just redo it here so you can actually see what I'm. So here is a terminal point, which is 2 root 5 p. So that's our reference angle first. Theta is equal to 0.884. Next, we will define the negative now. So theta then will be negative 2 pi as we go in the other direction, minus, plus, in this case, plus 0.84, 8410, which gives us negative 5.4421. So we can conclude possible values of theta are approximately 0.8 and negative 5.4. There's a second part to this with cotangent, but that follows the same procedures as what we did here with cosine. So you may want to try this question. It's on page 499. So this is your assignments. So that concludes this section on radian measures. So let's recap the past 4 lessons. We looked at converting between degrees and radians, determining the trig ratios of angles and radians, solving problems involving radians, and today, determining angle measures given a terminal point. Your assigned questions and for submit for marks from the example booklet. We looked at 3 example questions and how you find the value of theta.